Now we're going to do problems 11 through 15. So the first one says, solving graph negative x minus 6 is greater than negative 1. Just in case there's any confusion, this is problem number 11. So the first thing we need to do, we know that this is an inequality. So the few things about an inequality you always need to remember is that if you divide or multiply by a negative 1, you must flip the sign. But let's go ahead and start off solving for x. So the way we're going to start off solving for x is by getting rid of this negative 6. You get rid of the negative 6 by adding 6 to both sides. So then we can cancel out the negative 6 and the positive 6. So we get negative x is greater than 5. So now we want x, not negative x. So we divide both sides by a negative 1. So we get x is less than, because we must remember to flip the sign when we divide by any form of a negative. 5 divided by negative 1 is just a negative 5. So that's the solving part, but then also wants me to graph. So since it's just one variable, it means to graph on a number line. So let's start off creating our number line. And I want less than negative 5, so we know we need to go to at least negative 5. So I'm going to put a 0 right here and then just throw a 1 or a 2 to the right side. But I'm not going to really worry about the right side. Negative 1, negative 2, negative 3, negative 4, negative 5. And it says less than, not less than or equal to, just less than. So I'm going to go right up here to above negative 5. I'm going to draw an open circle. And I'm going to make an arrow going to the left, demonstrating that I continue to go to the left because it says less than. Alright, so that would be the answer to number 11. Let's go on now to number 12. Number 12 says, solve the proportion of 5 over 9 is equal to x divided by 54. Well, this is very similar to that flagpole shadow length problem. It's just a proportion, so you just cross multiply. 5 times 54 is equal to 9 times x. Well, if you have a calculator on you, just simply type in 5 times 54, and you're going to get the fact that that's 270 is equal to 9x. So now I'm divide both sides by 9. I know that 9 goes into 27 3 times. I know 9 goes into 0 times. So we get 30 is equal to x. And that would be the answer to number 12. So let's now go on to number 13. Number 13 says, determine whether the data set could represent a linear function. Now, I probably should have uploaded the data set into my picture here, but I did not notice this problem as being one I need to upload. So I'm just going to quickly write out my table. All right. Looking at this, we have to determine whether or not it's a linear function. We know linear functions, one, no x's can repeat. Well, that just makes it a function. We have no repeating x's, so we're good there. The next thing about linear functions, we have to have a slope. That means that it must be consistent in the way x's go with the same in the way y's go. So let's look at this first x, 0 to 1. That's a plus 1. F of x, 2 to 0. That's a down 2. X again, this 1 to 2. That's a plus 1. 0 to negative 2. That's also down 2. 2 to 3. That's also plus 1. Negative 2, negative 4. That's also down 2. So what you notice here is that for each x going up by 1, the y's go down by 2 each time. This means I have a constant rate of change, also called slope. So therefore, I can say that this is a linear function. So the answer would be yes, it could be a linear function. That's how you do problem number 13. So let's go on to problem number 14. Problem number 14 might be a little dark, but it says write the equation of the graph line in slope-intercept form. So let's just go ahead and remind ourselves that slope-intercept form is y equals mx plus b. So let's first start off by finding b. First find b. b is also my y-intercept, which means that's where I cross the y-axis. Well, I come up here and I notice that I cross the y-axis right here at 0, 4. So then I can write y equals mx plus 4. Now I need to solve for m. Well, it's very simple to solve for m. You just need to get another point. That's all you have to do to solve for m. So let's go over here and let's notice, it's kind of hard to tell, but you can notice that when x is 1, y is also 1. They kind of meet right there. I'm sorry there's no graph lines. I should have made this a graph line problem. So So now what we're going to do is we're going to take our y value of 1, because this is the point 1, 1. We're going to take our y value of 1 and plug it in for y, and we're going to take our x value of 1 and plug it in for x. So we get 1 is equal to 1 plus 4. So the next thing we're going to do is we're going to say y equals m plus 4, because 1 times m leaves me with just m. So now I'm going to subtract 4 from both sides because I'm trying to solve for m. So I get negative 3 is equal to m. So I now have my slope. I have a slope of negative 3. So I can simply say y is equal to negative 3x plus 4. That would be your slope-intercept form for this graph line equation. Now let's go on to number 15. Number 15 says find the slope of a line that passes through the points 3, 1, and 7, 9. Well, anytime we have 2 points and we want slope, 2 points and want slope, it is easy to use this formula. M is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So let's write our 2 points out to the side. 3, 1, 7, 9. Now we have a very simple problem here. We're just going to plug in either one of the y values first. So let's say I plug in 9 first. So I would say 9 minus my other y value from the other point, which would be a 1. So 9 minus 1 over, go back to the same point I started with. Since I started with this y being 9, I start with this x of 7. So I'm going to say 7 minus, go to the other x value, which is 3, so 7 minus 3. Now just do some simple calculations, and you get 8 over 4, 8 over 4, which then allows me to say that m is equal to 2. And that is how you do problems 11 through 15.